Hi everyone, my name is Nguyễn Huỳnh Đức, and this is my presentation for the term project of computer organization course, which is the emotibot emotional adaptive chatbot, which is implemented by using the finite state machine. So we will jump to the next part. So my intended project is to create a virtual AI chatbot like this. As you can see, this is the product of Willbot. They create a chatbot that can respond to the human response based on the feeling and the current mood of human. So the product I create lead more toward understanding human behavior by depending more on the current state of emotion when communicating and the current human response to react and feedback, as it may be suitable for individuals or partially sensitive to external feedback, given its significant influence on their emotional state, especially those facing serious psychological challenges. So that's also the motivation that I created the chatbot. My product is based on the Disney animated film Inside Out, which I have seen with my family. As you can see here is one of the scenes in the movie. In the film, I believe that in addition to the main character Riley difficulty responding to the emotions she experienced internal, some external factors such as the response and behavior of others in her daily life, such as their parent in here, also have an impact on the problems she faced during her adolescence. So I creating a chatbot like this will allow for faster analysis and processing of input information. This will result in appropriate transition between emotional state and the most optimal response for people, especially for those with psychological problem. So here is my product description. It's drawing from human reaction and feeling. My circuits was implemented on circuit first will encode some specific term that human enter from the keyboard, like they are feeling sad or happy, and I will use some logic gate to encode them to the binary form to categorize their response that embody those sentiments. Therefore, the system can transition to suitable emotional condition in the machine and subsequently providing the fitting reply to enhance the current mood of human based on their current emotion and response. So here is the logic design that I think and create for my machines. To represent human mood, the input state and the output value that I choose the method to scale them to a range of decimal value. As you can see here, the input I would scale from -2, -2 to +2, and the state would scale from -2 to the 1. So all the input represent the human mood, and the state in the machine is also scaled to range of decimal values. So each state will always transition to another state by combining the value of the current human mood with the input given to move to the next state, and so on. In addition, the following section below will describe additional condition and rule in the logics. So here is the condition for the output. If the human mood is below -2, the machine will give therapy, and if the human mood is now equal to -2, the machine will just give advice, and if the human mood is equal to -1, the machine will sympathize for the human, and if the current mood is now 1, the machine will react positively, and if the human mood is now 2, the machine will react overjoyed. So here is the condition for the machine to release the output based on the scale I have mentioned above. So here are some key features that the next state and the output will be designed based on the state transition, based on the current mood and the input value. Like the calculation, it will calculate by using the current mood plus the input value by the scale I talk above to move to the next state and release the appropriate output based on the calculation. And as you can see, that is quite similar to the vending machine implementation that we have studied in class, because uh, because here's the rule and the condition of the machine. Like the vending machine, when the human mood reaches a certain threshold, like a certain threshold that I set here, which is below or equal to 2, or I'm sorry, larger or equal to 2, or below or equal to -3. So the machine will reset the score and back to the initial state, neutral, and then it will keep the remaining scaling score of human mood to move to the next state. As you can see here, it's quite similar to the vending machine logics. So here is the example. For example, if the machine is at the state joy, so now the human mood is equal to 1, and the input that is given to the machine is +2, which is the positive trigger. So the total score of human mood now is 1 plus 2, which is now 3. So as I mentioned above, when it's equal to 2 or larger than 2, the machine will back to the neutral state and reach the remaining score. Here now is 1 to come to the next state, which is the choice state. And there is no output when the human mood is equal to 0. In this state, the machine will in the idle state and wait for the next response. Here is the finite state machine diagram of my products. So I will take an example for you to easily visualize how my project works. So for example, we will start at the neutral state, which have the mood scale equal to 0 based on the rank of scale I talked above. And for example, if the human mood now is positive, they like enter from the keyboard that they are happy, and the program will categorize it as positive input. And based on the calculation I talked about, it will use the current state plus the input to move to the next state and generate appropriate output. So now we are in the neutral state with a 0 and plus 1 from the positive. So the total now is 1. And 1, if the human mood is 1, it will react positively and move to the state which is equal to 1, which is joy. So now we are in the joy state. And for example, if the user receive extremely happy news like that, the program will categorize it as the positive trigger. So because now the human mood now is 1 and plus the positive trigger would be true, so now the total score of human mood now is equal to 3. And based on the condition I talked above, when the human mood is equal to true or larger to true, the machine will use that score to back to the initial state and use the remaining score to move to the next state. So because it is 3, which is larger than true, it will back to the initial state, which is neutral. And because it still had 1 point left, 1 point remaining, so it will move to the next state, which is joy again. So here is the reason why when the input is positive trigger, the state transition is staying and not staying at joy. So here is the quick example of how my machine works. As you can see, it's quite similar to the vending machine. That when it's meet the threshold, the machine will reset the score and use the remaining score to move to the next state. So here is the binary modeling that I use to encode the human input and the state and the output that the machine released. So because my algorithm use 4 input, 4 state, and 5 outputs, so I think binary encoding is suitable with the designs of small amount of input and state. So here is the state encoding. Because there are 4 states, so it needs at least 2 bits to represent each state by using the equation of log. So for the neutral is 0, 0, for the joy is 0, 1, sad is 1, 0, distress is 1, 1. And for the input encoding, based on its state transition, only one input, positive, negative, or negative trigger or positive trigger turn on. So it is the one hot encoding. So only one input active 1 at a time, and the other remaining inactive 0. For the output encoding, by using because we are using the binary encoding, so we will use the equation of log. Log 2 of 5 is approximately to 3, so it will need 3 bits to represent each state of the output, as you can see from here. So for the block diagram, because as you can see that because the next state of my machine is based on the current state and the input, so the suitable final state machine I use for my products, that is the melee machines. Because the amount of input and outputs is larger than the state, so melee machines are more flexible in dealing with this situation. And I thought to react appropriately to the user input, the output, the response, and the next state must consider both the current state and the input. So that's why the melee machine is used. And here is the block diagram of traditional melee machines. So here are the state transition truth table of my machine. And here is the first few rows of the truth table. The total rows of my truth table is 16, and here is the expression that I acquired and simplify it as much as possible for easy to when implementing in Circuit. And here is the output truth table, and here is the expression I acquired from the output truth table based on the current state and the input here. So here is the part of my implementation of my product. It's a master-slave flip-flop which works as a memory proponent to store the current state and the next state of my machine. It has 2 parts, which is the master latch and the slave latch. When it from 1 to 0, the master latch will be the bit will be stored in the master latch, and when it from 0 to 1, the bit will be stored in the slave latch. For example, if the next state is now 1, so you have to click to the clock 2 times to update the current state. So 1, 2, so now the current state is now being updated, because in the master slave flip-flop, the current state will be updated when the clock change from 0 to 1. And as you can see here is the complete circuit, the whole complete one with the combination of a lot of NOT, OR, and gate function as the logic expression of the next state and the output based on the combination of the input here and the current state. So here, this is the part of the product where the user can interact with the prototype. So the user will interact with the 4 input button by clicking to one that represents their current mood. For example, if they are feeling good, which represent the positive one, they will click here. And the machine will use the logic to transit between the state inside and release the outputs here as the appropriate response for our beloved users. So here is the thing to remember, that after choosing any of the input, the user have to click to the clock 2 times. So if it is 1 and 1 time, if it is 0. So if the clock now is 1, the user have to click it 2 times. And if the clock now is 0, the user just need to click it 1 to update the current state. Because this is the master slave flip-flop. This is the master slave flip-flop, so the next state only update when the clock change from 0 to 1. And another thing that the user have to notice, that they only turn on one input. When one input is turned on, the other input have to be turned off to make sure that the circuits don't mistake when the user choosing a lot of input. So have to remind that only one input is turned on. So now we will come directly to the demo part. So let's see if my product work the same as the step diagram and the logic I mentioned above. So let's go. So let's start with the initial step. So let me reset anything as I mentioned above by choosing every input is 0 and click the clock 2 times. So now our machine is reset and we are in the neutral state when nothing happened. So for example, if the user is having a positive mood right now, so they will click on the one that represents it. For example, they feel something positive and they click I feel good. The state now will move from neutral to the joy state, and the machine now react positively, which is that's great. And as you can see here, then based on the rotation I mentioned, the user will click on the clock 2 times to update their current state and ready for the next input. So they click to the clock 2 times, 1, 2, and now the current state is now update, that is moved to the joy state. As you can see here, the current state is now updated to joy state, which is 0 and 1 to represent the user current mood. And if we, for example, if we assume that the user don't change the input, the machine will still receive the input which is positive. As you can see here, the machine will still receive the positive input. And based on the logic I mentioned in the part 2, which is the logic design, the scale of the human mood is now calculated that which is 1 plus 1, which is 1 from the joy state and plus 1 from the input. So the total of the scale in the human mood right now is equal to 2. So the next state will be, as you can see here, the next state will be the neutral state, because based on the logic I designed, if the human mood reach the threshold 3 or minus 3, true or minus 3, the machine will reset the score and back to the initial state. And because the scale of the human mood now is true, so the machine will release the overjoy output. So now you can see here, it's not released that's the positively output, but it's released the overjoy output because the scale of the human mood now is true. I talk as it is used the current state, which is 1 plus 1 from the input. However, we still not update the current state right here. We still not update the current state. We still did not click the clock 2 times. So if I assume that the user mood suddenly change to something extremely bad, that make them click to something negative trigger, that's here. So I turn off it here and I click here to assume that the user experience something extremely bad. And so because they are in the joy state, which is 1, and they receive the negative trigger, which is minus 2, 1 plus minus 2 will be minus 1. So the next state will be set, because set is equal to minus 1, and the output is also equal to minus 1, which is the output the machine will sympathize for user. This is quite true with the logic here is quite true with the real scenario outside, because you have received something, you are in the joy state, because you have received something that make you happy, but you receive something that's extremely badly affect your mood, which is the negative trigger. Instead of going to the distress state, you will receive something less bad, which is the sad state, and the output here is just the sympathy one. So I will take a real life scenario for you to see that if my logics compared to the real life, it still makes sense. For example, if you are in the joy state because you are being invited to the party like that, and then you suddenly receive something that's caused a negative trigger. For example, if you are receive an extremely bad score in exam, and because instead it will moving to the distress state, it just come to the sad state, because the intensity in your sadness is not enough to come to the distress state, because you have received some happy news before, like you are being invited to the party, And now, although you are receive something that's called a negative trigger, you you still feel not you still not feel something like not distressed enough because you still being invited to the party, like I said. But if for example, if you are in the neutral state, let me reset on the state. So if you are in the neutral state and you receive something that's got a negative trigger, for example, so you can see here, instead of going to the sad state before, it will go jump directly to the distress state, because you will not receive something happy like I said before. You are just in the neutral state and you receive something that's called a negative trigger. For example, you're having a math score in exam, so the machine will jump to, it will assume that you are really distressed, so it will give an output that's matched with your sadness intensity. That it will give an advice for to enhance your mood. So this is the feature that I apply to my logic. That's it. The human mood is based on their current state and the input, not just only the input or not just only the current state. And this logic is still matched with the scenario. This logic is based on the scaling to the rank of decimals. I see that it's still matched with the scenario in the real life. So when I'm take a reflection of my current product with the proposal I make before, I think the difference between the proposal and my final product implementation is that both the number of output and the state of my final product is increased with more condition applied to the logic of the circuit to make it more appropriate to the actual scenario in real life at the example I give to you in the previous part. However, the logic of the scaling to the human mood to a certain range of values is still keep till the end of the project, which are the things I'm most proud of and glad about. Additionally, except for everything I keep from the project progress reports, there is also one thing that I changed. That is the way of writing the logic expression for the next step and the output. Because in the progress report I submit, I did not notice that every input combination is the one-hot encoding. That's the only one input is on, and the other input does not matter. So when I write the expression, I suddenly include all the input combination, which make my expression was a bit lengthy and complicated in a very unnecessary way. Therefore, I have already shortened it in the final report and the implementation I just give to you in the previous slide. For the product feature work, I think the current product still miss a lot of part and feature function compared to the one I imagined in my head when starting doing the project. Because it used by real customer and used to solve the problem of some people I mentioned in the motivation part, the function of the current product is not enough. So if possible, I hope in the future I could extend the product capability such as we could add more input state add more input or state and the output to fully cover all the scenario could happen in real life. Because for the scenario I given to you in the example, just some of the very basic scenario, there is many other scenario in real life that still not mentioned in the logic of my circuits. Secondly, I think that I can try to buy an NLP, a natural language processing system that could process human language and map them to suitable input encoding for the following step. And I think I can improve the algorithm by combining with the logic expression used in this project to make the machine's transition process more appropriate with more flexible output generate. And for the reflection of the Tom project, I think I have applied quite a lot of knowledge and skill with they are both from the learning objective of the course I acquired when doing the project. First, that I learned to design and implement the final state machine and construct a binary model and state transition, design a logic circuit with the milling machine I applied to this project, and simplify the logic expression and implemented the circuit at the gate level I showed to you guys in this circuit first. I think that I also gained some project management skill, like I divide the complex problem into manageable components that help me not stress at the end of the semester, and the time management is also important for this multi-stage project. So this is the end of my presentation for the final project of computer organization course. I hope you guys will enjoy it.